So we're continuing to talk about the factors that contribute to obesity, and I started talking about the brain control of eating behavior. There is an interesting syndrome called Prader-Willi syndrome, and it's characterized by some mental deficits plus an excessive appetite. I mean a voracious appetite. These kids cannot, and adults too, always think about food, always are hungry, have this insatiable desire to eat. If they don't have access to food, they'll start throwing tantrums. That's all they think about. So typically, if they live at home, all the cabinets have to be locked. The refrigerator has to be locked. They have to be prevented from going outside because they'll start rummaging through trash cans that are out to look for food. Their appetite is that voracious. So typically they end up living in, they're institutionalized or live in group homes in a tightly controlled environment. I've seen a documentary on one woman with Prader-Willi, and they live kind of in a remote area so that they can't leave and seek food on their own. They do a lot of exercise, and the food environment at the group home is really controlled. I did put up a YouTube video that you can watch on Prader-Willi syndrome. It's on Blackboard. So we're going to talk about the feeding and satiety centers. The hypothalamus in the brain, it's embedded deep within the brain, has two different regions that help control appetite. The feeding center and the satiety center. The feeding center, when it's stimulated, increases the desire to eat, and the satiety center, when it's stimulated, it decreases the desire to eat. So they've done a lot of experiments in rodents, and they find that if you destroy the feeding center in the rat's brain, they stop eating and will actually starve. If you stimulate the feeding center, they'll overeat, become obese. If you destroy the satiety center, the rat will eat and eat and eat and become obese. If you destroy that should be the satiety center, if you stimulate the satiety center, then the rat will stop eating. Sorry about the typo. So the feeding and satiety centers receive information from the periphery. By that I mean the digestive tract and fat, basically, and pancreas that activate and inhibit the feeding and satiety center depending on whether the person's in the fed state or fasted state. So the gut hormones, there are several, we'll talk about them. As you're eating, a hormone called PYY, I don't know why they couldn't come up with a better name, but PYY is secreted as you're eating when food enters the digestive tract and sends a signal of fullness to the brain. Ghrelin is the hunger hormone. It's secreted in increasing amounts between meals and signals the brain that you're hungry. It increases the appetite. Insulin provides a fed signal to the brain. It's released when carbohydrates are absorbed into the body when you're eating. Leptin is another hormone. It's secreted by fat cells in increasing amounts as you're gaining body fat, and provides a signal to reduce the appetite. So you can see that the body tries to help you maintain a healthy weight by adjusting your appetite when needed. So there's a homeostatic mechanism to try and help you maintain a certain body type or body fat. This is an illustration of the brain control of eating behavior. The pink is the brain, and purple is the feeding. The purple is the feeding center, yeah. And the light green is the satiety center. So when you stimulate the purple or feeding center, it releases some neurochemicals, specifically called neuropeptide Y and agouti-related protein, that when they're released increase the appetite. And the satiety center, when it's stimulated, it release pro-opiomelanocortin, which is a neurochemical that decreases the appetite. So you can see the various inputs. You can see that the digestive tract releases PYY336 that inhibits the feeding center, and it actually stimulates, inhibits the feeding center and stimulates the satiety center. Ghrelin is the hunger hormone. It stimulates the feeding center. Fat tissue releases leptin that stimulates the satiety center and inhibits the feeding center, and the pancreas releases insulin that stimulates the satiety center and inhibits the feeding center. There's a lot of other hormones that provide input, but these are some of the main ones. So we do have some mechanisms in place to try and help us maintain a healthy body fat level, but unfortunately in these days, the appetite regulation mechanisms that protect us against starvation are much more robust or powerful than the mechanisms to suppress appetite to prevent obesity, because throughout human history, starvation has been the primary concern. So humans developed really good mechanisms to increase the appetite and increase the desire to eat when there wasn't enough food available. It's only in fairly recent human history that food excess has been an issue and obesity has been a problem. So we haven't developed great mechanisms to reduce the appetite when there's an energy surplus. So some people do think about food more than others because we're wired differently. Some people will eat excessively even if they have a lot of discipline in other areas of their lives. And this is really important to think about because we talked about weight bias. And some people think that all people need to lose weight and keep it off is willpower and self-discipline. Well, when you're wired to have an excessive appetite or have some type of appetite dysregulation, it's more than willpower. You're fighting biology. Okay, so it is harder for people who are wired to have excessive appetites to maintain a healthy weight. So, they have to compensate by being extra careful about their environment so that they don't have as many cues to eat or as much food available, and they need to be really diligent about exercising. And the opposite is also true. It's very difficult for some people to gain weight. There's some people, I had a student one time in his diet analysis, he said, if I didn't have to, I wouldn't eat. I consider food and eating a nuisance. He just had a very low appetite. So he had kind of a different wiring than a lot of people. And it was really hard for him to get himself to eat in order to maintain his weight. So appetite dysregulation is a real thing. There are some people who are born wired differently, and then there's some people who develop appetite dysregulation because of ignoring their hunger and satiety cues over years, and chronic consumption of a highly refined diet that has a lot of processed foods that are high in refined carbohydrate, sugar, fat, that can result in alterations of the hypothalamus such that the satiety center doesn't register satiety signals as well. Now, this is a problem because if you've consumed a poor diet over time that's resulted in weight gain, you have developed you've kind of changed your wiring. You've changed your appetite regulation mechanisms. And the question is, can they get back to normal? Can you repair that so that you do register the fullness when you need to, so that your appetite is reduced when it's supposed to? And a lot of people think that you can reverse appetite dysregulation that's been caused by long-term consumption of a high, the Western diet, basically, a high processed food diet. And it may be reversible if the person can follow a healthy dietary pattern over quite a long period of time. They may go back, the appetite regulation mechanisms may go back to normal. Now, food addiction is controversial. I know a lot of people who don't believe in it, but in my practice and reading the science, I kind of actually do. The people who don't believe in it, it's like, well, how can you be addicted to something that's needed for life? Well, we don't need these highly processed foods. We've developed foods that have a lot higher sugar content than you would ever find in nature. We've disconnected the fiber content with a lot of foods through processing and refinement. So there are foods that are higher in sugar, fat, and salt than you would normally find in nature. We eat these, and we eat them in combinations, the sugar, fat, and salt in combination. So food manufacturers, food scientists have figured out the combination of fat, salt, and sugar in foods to hit what they call a bliss point. They also have figured out textures. I saw a kid interviewed, he was eating flaming hot Cheetos, and he said it's like a party in your mouth. Okay, so what happens is when you eat some of these foods that are, high in sugar, fat, salt, or have these combinations that hit the bliss point, that bliss point is when you get a rush of dopamine in the brain or opioids, and they're feel-good hormones or neurochemicals. Same systems that are activated by cocaine. So they've done studies where they've given mice access to water with cocaine and water that's sweetened, and the rats or mice will actually prefer the sweetened water over the cocaine and drink a lot of it. So a pleasurable experience with food can cause dopamine release when you just have a cue related to that food, I know one of my cousins, when she was little, whenever she would see the 7-Eleven sign, that would be a cue for her for a Slurpee. And so, she would start asking for a Slurpee. If you smell a certain food that smells really good, that can motivate you to try and seek that food. So these cues to eat stimulate a motivation to go get the food. Dopamine is a motivating hormone, so a little bit of dopamine increase motivates food-seeking behaviors. Then when you eat that food, you finally get to it and eat it, you get the big dopamine hit. So I have seen this, especially when it comes to sugary beverages. I work with people with diabetes, and the pregnant women with diabetes, we're very strict on their blood sugar control because of the harms that can develop in the fetus with exposure to excess sugar. And one of the hardest things for them to give up is sugary beverages like soda and sweet tea. And then I myself had what I think was an addiction to regular soda for a long time that developed when I started drinking a soda that had caffeine, sugar, and the cold in the bubbles. It was the perfect combination to give me that lift, that boost I needed to get through the day when I had untreated thyroid disease. And I developed an addiction to that over time. So the thyroid disease, when it was treated, I didn't lose that addiction right away. It took me quite a while, in fact, going to an area in Hawaii for a workshop, actually. Poor me going to Hawaii for a workshop. It was an eating disorder workshop for professionals. And we were in a really remote area where I didn't have access to soda for a week. And when I came back, I just didn't go back to it. So another thing about another indicator that some people may have a food addiction is that they've done brain imaging studies and have found that some obese people take longer to get the dopamine release from eating. I'm thinking of the study that I looked at from eating or drinking a milkshake. So they think that addiction-prone people may be born with fewer dopamine receptors, so they need more of the stimulating food, like sugar, for example, to get the dopamine reward that they're seeking. Okay, let's see. I'm going to stop there and start talking about, continue this in the next segment.